Welcome to IT Learning, the place where everyone can learn the basics of the IT world. Today, we're going to dive into a fundamental building block of the Internet, the Internet Protocol, or IP for short. Just like your home has a specific address to receive mail, each device connected to the Internet has a unique IP address that allows data to find its way. It's a crucial part of how the Internet functions. There are two versions of this protocol in use today: IPv4 and IPv6. They both serve the same purpose but in slightly different ways. Imagine them as two different types of mail systems, both delivering letters, but each with its own unique process and format. In this video, we will focus on understanding what IPv4 is. So if you've ever wondered how your device communicates on the big wide web, stick around. It's time to unravel the mystery of IP addresses. IPv4 stands for Internet Protocol version 4. It's the fourth iteration of the Internet Protocol, but don't let that number fool you. It's been the standard for quite some time, and it's integral to how we navigate the vast digital landscapes of the Internet today. At its core, IPv4 is like a global positioning system for devices connected to the Internet. Every device, be it your personal computer, your smartphone, or even your smart fridge, has a unique IPv4 address. This address is crucial because it helps in identifying where information is coming from and where it should be delivered. Just like how your home has a unique address for receiving mail, your devices have unique IPv4 addresses for receiving data. Now you might be wondering, how does IPv4 achieve this? The answer lies in its numerical system. IPv4 uses a 32-bit numerical system. That's a lot of numbers, right? But this is what allows for a vast number of unique addresses. To put it in perspective, imagine a city with millions of houses, and each house has a unique address. That's what IPv4 is doing on the Internet. The numerical system in IPv4 is divided into 4 octets, or sections, separated by periods. Each octet can hold a value between 0 and 255. And it's the combination of these 4 octets that makes up the unique IP address for each device. In essence, IPv4 is the backbone of Internet communication. It's the invisible force that ensures your emails reach their destination, your web searches find the right pages, and your online gaming sessions connect to the right servers. Without IPv4, the Internet as we know it would be a lot messier and a lot less efficient. So, IPv4 is more than just a string of numbers. It's a system, a protocol that organizes the chaos of the digital world into an ordered and navigable space. IPv4 is like the postal system of the Internet, delivering information packets to the correct address. An IPv4 address consists of 4 numbers separated by periods. Imagine a house in a vast city. The city represents the Internet, and the house is a device connected to it. Just like each house needs a unique address to receive mail, each device needs a unique IP address to send and receive data. IPv4 addresses are written in decimal, and each of the 4 numbers can range from 0 to 255. That's because they are represented by 8 bits, or a byte, and the largest number you can represent with 8 bits is 255. So the structure of an IPv4 address is like a series of 4 rooms, each filled with a number from 0 to 255. The rooms are separated by periods, much like how rooms in a house are separated by doors. Now, if you calculate the total number of unique combinations possible with this structure, you'll get over 4 billion unique addresses. That's right, 4 billion. It seems like an astronomical figure, doesn't it? But let's put this into perspective. The Earth's population is over 7 billion. Now consider that each person may have multiple devices such as smartphones, computers, and smart home devices. Suddenly 4 billion doesn't seem so large, does it? Here's another way to think about it. If IPv4 addresses were grains of sand, they'd fill up a large sandbox. But with the number of devices in the world today, we'd need a sandbox that's twice as big. So while the structure of IPv4 allows for over 4 billion unique addresses, it's not enough to keep up with the rapid pace of technological advancement and the increasing number of devices that need to connect to the Internet. Despite the large number, the world is running out of IPv4 addresses. We're like a growing family running out of rooms in our house. But don't worry, the IT world has a solution for that, and we'll explore it in the next scene. With the rapid growth of the internet, IPv4 is facing a major issue. You see, IPv4 uses 32-bit addresses, which means it can support roughly 4 billion unique IP addresses. Sounds like a lot, right? Well, as our world becomes increasingly interconnected, we're swiftly running out of these addresses. Now let's put this into perspective. There are over 7 billion people on the planet. If everyone had a single device that needed an IP address, we'd already be out of IPv4 addresses. And we know that's not the case. Many of us have multiple devices, smartphones, laptops, smart TVs, and the list goes on. So what's the solution? Enter IPv6. IPv6 uses 128-bit addresses. This means it can support an almost unimaginable number of unique addresses. Think billions upon billions. With IPv6, we're less likely to run out of addresses anytime soon. Now, despite the clear advantages of IPv6, the transition from IPv4 is slow. This is due to several factors, like the cost of upgrading hardware and software, and the fact that IPv4 and IPv6 aren't directly compatible. So, as we transition to IPv6, understanding IPv4 remains crucial for anyone interested in IT. It's like learning the history of a subject to better understand its present and future. So keep on exploring, keep on learning, and let's navigate this digital world together. So, that's a brief look at IPv4. We've delved into its importance in internet communications, enabling devices worldwide to connect and share information. We've also dissected its structure, revealing how each part plays a crucial role in data transmission. As we look to the future, IPv4 remains a fundamental pillar in our digital world, despite the emerging IPv6. Understanding it is key to grasping the complexities of the internet. To continue learning new IT knowledge, feel free to subscribe and leave a comment about which topic you'd like a video on.